In this video, we shall be looking at how to apply logarithms. Logarithms can actually be applied. How can they be applied? Okay. Logarithms can be applied in indices. Good. So on the board here, we have an index equation, and this index equation is seemingly impossible to solve. Why? Because the bases are different. Now, the interesting thing I want to let you know is this index equation can actually be solved, and it can be solved by the application of logarithm. That is the beauty of logarithm. So logarithm is now helping us to solve an index equation that in which the bases are not the same. Good. So how do we go about solving such an equation? By the application of logarithm. Now, the first thing we do is to take the logarithm of both the left hand side and the right hand side of this equation, and the logarithm we are taking is the common logarithm, which is logarithm to base 10. So the first step I'm going to take in solving this equation is to take the logarithm of both sides. So I'm taking the logarithm of 2 raised to the power of 2x minus 1, which is equal to logarithm of 5 raised to the power of 2 minus x. Now, some of us might be asking, there is no base in this expression. So what base should we use when a logarithm must have a base? Good. Yeah, a logarithm must have a base, but when the base is not there, we assume the logarithm is of the base of 10. So in this case, since the base is not written, the base is going to be taken conventionally as 10. Okay, so now we are going to proceed with the laws of logarithm. Now, from the laws of logarithm, we know that a logarithm raised to a given power can be written as the logarithm multiplied by that particular power. So the power of this, the name of this logarithm, which is 2, can be taken to multiply the logarithm, so that we have this power 2x minus 1 multiplying this logarithm, that is 2x minus 1 into logarithm of 2, to be equal to 2 minus x into logarithm of 5. That is, when I say into, I mean multiplication. Into is similar to, or is another way of saying multiply by or times. So if I say 2x minus 1 into logarithm of 2, I mean 2x minus 1 multiplied by logarithm of 2. So now, from that, we have now applied the law of logarithm, which says the power of a logarithm can actually multiply the logarithm. It's permissible. That is a law in logarithm indices. That's one of the laws of logarithm, sorry, not indices. So by that law, we have been able to translate the power of this logarithm to become the coefficient of the logarithm rather. So now we have 2x minus 1 multiplied by log of 2 to be equal to 2 minus x multiplied by log of 5. So now we are going to quickly punch our calculator to get what logarithm of 2 is. So I'm going to quickly punch logarithm of 2, and on my calculator it is giving me, so we have 2x minus 1 multiplied by logarithm of 2 is giving me 0.3010, which is equal to 2 minus x multiplied by logarithm of 5 is giving me 0.6990. Good. So the next thing is to open this bracket with this value that is outside. So I have 0.3010 into 2x minus 1 to be equal to 0.6990 into 2 minus x. Good. So now we have the task. The task that lies ahead of us now is to open this bracket. So I'm going to use 0.3010 to open this bracket. So 0.3010 multiplied by 2x is going to give us 0.3010. Now 0.3010 is the same thing as 0.301, because this 0 is not meaningful because it's on the decimal side. Likewise, this 0 is not meaningful, so we can actually neglect it. So we can rewrite this as 0.301 multiplied by 2x minus 1, and that will be equal to 0.699 multiplied by 2 minus x. So 0.301 multiplied by 2x, punch our calculator, 0.301 multiplied by 2 is going to give us 0.301 multiplied by 2 is going to give us 0.602x minus 0.301 multiplied by minus 1 is going to give us 0.301, which is equal to, on the right hand side we do the same thing, We have 0.699 multiplied by 2. 0.699 multiplied by 2 gives us 1.398. That is 1.398 minus 0.699 multiplied by x is going to give us 0.699x. 0.699x. So by opening these brackets, we have 0.602x minus 0.301 to be equal to 1.398 minus 0.699x. So the next thing we are going to do here, we are going to make sure the like terms are on the same side so we can be able to simplify. So I'm going to move all the terms on x to one side of the equation and the terms without variables to the other side of the equation. So if I'm going to move this 0.699x to the left hand side, then I'm going to have 0.602x, which was originally on the left hand side. So I'm moving the x term on the right hand side to come and then be on the same side with the x term on the right hand side. And the x term on the right hand side, the x term on the left hand side, and the x term on the right hand side is 0.699x. So I'm bringing it over, knowing that the sign must have to change since it's crossing the equality sign. So it becomes plus 0.699x, and this is going to be equal to, sorry, the space is not enough, so this is the same line of the equation. So what I'm writing down here is the same equation. So this is equal to, now I'm bringing this constant term at the same time to this other side, and the constant term was initially minus 0.301, so it becomes 1.398 plus, because this number was initially negative, plus 0.301. Good. So we quickly punch our calculator. We have 0.602x plus 0.699x. So we have 0.602 plus 0.699. That gives us 1.301. So this is 1.301x, which is equal to, we have 1.398 plus 0.301, and that gives us 1.699. So at this stage, as usual, we have 1.301x to be equal to 1.699x. So we divide both sides by the coefficient of x here so as to get the value of x. That is, the coefficient of x in this case is 1.301. So I'm going to divide both sides by that coefficient. So we have 1.301 divided by 1.301, which is equal to 1.699 divided by 1.301. So 1.301 divides out itself once. So we are left with x on the left hand side, which is equal to 1.699 divided by 1.301. So we have 1.699 divided by 1.301, and that gives us, we have 1.699, divided by 1.301. So that gives us 1.306 approximately. So that is an approximated value. That is, to 3 decimal places, our value of x is going to be 1.306. And this is how we apply logarithms to solve index equations. It's very simple and straightforward. If you follow these procedures, we can be able to solve any index equations in which the bases are not the same. Thank you for watching my video on the application of logarithm, and please stay tuned by subscribing to this channel so that you'll be notified, because I'm going to make more videos on logarithm so that we can be able to understand logarithms better. Thank you very much and stay safe.